Hi friends, welcome back. Today we're talking about side angle, side congruency in triangles. If you have two triangles and you prove that there's two sides and the angle in between those sides are the same, then those triangles are congruent. So be very careful, that angle has to be between the two sides. So for example, if I have a triangle like this and a triangle like that, I'm the worst at drawing triangles. I don't know how this has happened. I've been doing this for 20 years and I still can't draw a triangle. But let's say we got this side is congruent to this side is congruent to this side. This angle right in here between those is congruent to this angle. I can say, well, then these two triangles are congruent. There's no other way around it. You can't have two sides and the angle in between them congruent without the triangle itself being congruent. So let's use this in a proof. All right. So before we go any further, these are my notes for triangle congruency proofs. Just write them down. We're going through them as we go through these various side angle, side, and I'll explain them as we go along. First things first, we are given AD is congruent to BC. So AD is congruent to BC. All right, and then we know angle, words are hard. Angle ADB. So ADB, so that's this angle right in here, is congruent to CBD. CBD, so that's this angle right in here. We know those two are congruent. Now let's prove triangle ADB is congruent to CBD. Well, the first thing we do on our triangle congruency is we do our givens. Next, we're going to do any definitions, which are midpoint and bisector. I don't see, for the most part, I don't see any definitions that we need here, but now, so we're going to skip that for now. Number 3 is what I like to call our obvious but not givens. Those are things like vertical angles, parallel line, angle relationships, reflexive property. Now remember, in a previous lesson, we learned the reflexive property is one that shares a wall, and you'll see right here that shares a wall. So if I were to separate out these two triangles, I could say, hey, these lines are the same because they're the same line. So the first thing we're going to do is write down your givens, okay? Let's write down your givens. Next step, we are going to say, and this is where it is vitally important, for this reflexive property, we've got to be very careful with our congruency statement. You see that we have DB here and BD here. So we would say side DB is congruent to side BD, and that will help us with our congruency statement. So for number 2, that is the reflexive property. All right, reflexive property. Now, once we have done that, we can now generally say side angle side, angle side, that kind of thing. And since we're specifically talking about side angle side, if I were to separate these triangles out, you'll see that I have side, angle, and side. And again, that angle has to be between those. So I can say triangle AB or ADB is congruent to triangle CBD because of side. So I have now proven what I set out to prove. All right, let's try another one. So along those same lines, we're going to do this guy right here. Okay, so given that BC is congruent to DA, all right, BC is congruent to DA, and BC is parallel to AD. Okay, this is good. BC is parallel to AD. All right, so those two guys are parallel. Then prove that this triangle is congruent. Okay, well, the first thing that we do is we write down our givens, right? So those are there. Next, we're going to do any definitions. Midpoint, bisector, I don't see that on here, so we're good to go. Obvious but not givens. Vertical angles, parallel line, angle relationships. That's things like interior, exterior, alternate interior, alternate exterior, that kind of thing. And then the reflexive property. Okay, so the parallel line angle relationships, that's when you see these parallel lines. So I see these parallel lines here and I think, I got to write some angle relationships. Because these two are congruent, right? That means that this angle right here, BCA, and it does help to have different colored pens and markers or colored pencils as you're doing this, because then you can identify these. So BCA is this guy right in here. That is going to be congruent to DAC because they are alternate interior angles. So we can say BCD, angle BCD is congruent to angle DC, or whoops, I'm sorry, DAC. DAC. And that is because of they are alternate interior angles, and alternate interior angles are congruent. So you can say alternate interior angles are congruent. Okay, so now we have angles and we have one side. Remember, we're doing side, angle, side here, so the angle must come between the two sides. Well, also with my obvious but not givens, I did vertical angles, we don't have any of those. Parallel line angle relationships, reflexive property. I see a reflexive property right here. AC is going to be congruent to, so AC is congruent to CA for this other triangle, CA. So you got to be careful with your congruency statement there. And that is the reflexive property. Okay, so using these rules as a guide, right? It's not always going to work out for proofs, but this is a good guide. It'll get you like 80% of the way there. The next step is side, 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 angle, side. Well, at this point, if I separated out these two triangles, you would see that I have, so if I separated this guy out and then I separated this guy out, I cannot draw triangles. Terrible. This is congruent to this. This guy is congruent to this, and then this angle is congruent to this angle. If you take a look at one of them, you'd see side, angle, side. So now I can say that triangle. So number 4, we've got triangle. I hope could you see that in there? Yeah, there we go. Side, angle, side. All right, so AB, I try to record these close so that those of you who are on your phone can see it okay. So triangle ABC. Now let's go back up. ABC is congruent to CDA. And sure enough, that is the right congruency statement we got there. And that is because of side, angle, side. Excellent work. I look forward to seeing you next time when we talk a little bit more about some of these proofs. Great job.